Welcome to solverfy.
All right, guys, we're doing problem number 18 of chapter 18 in Chemistry Essential Science. So in CF3Cl, the CCl bond dissociation energy is 339 kilojoules per mole. In CCl4, the Cl bond dissociation energy is 293 kilojoules per mole. What is the range of wavelengths that can cause CCl bond to rupture in one molecule but not the other? So we can look at this in terms of energy. So I have our molecules here ranked with their bond dissociation energy. So at these lines, these would be the minimum amount of energy needed to, break the CCl bond. Down here, we would have 0 bonds being broken. You would not have enough energy. Up here, this would be the minimum amount of energy to break the CCl bond in CCl4. And in this area, you would have enough energy to break this CCl bond, but not this CCl bond, because the minimum amount of energy would be here. So above this, you would be able to break both. Now, so that means that in this region right here, this is where you're able to break the bond of one, but not the other. Now we're going to use our equation E, and lambda is equal to NHC over E to calculate our wavelength. Let me see if I can shrink this. So lambda 1, we're going to use CCl4 first. So in this equation, we're going to use Avogadro's number, 6.02 times 10 to the 23rd inverse moles. (6.63) times 10 to the negative 34 joule seconds times 3 times 10 to the 8 meters per second. Nice. Then we're going to put this over 293 kilojoules per mole. And then we're also going to multiply this by the conversion factor, 1,000 joules per kilojoule. So that means lambda 1. We're going to put this into our calculator. So this is going to be at 409 nanometers. Now for lambda 2, we're going to have 6.02 times 10 to the 23rd inverse mole. And then we're going to divide that by our energy. 339 kilojoules per mole times 1,000 joules per kilojoule. So this is going to be lambda 2 is S. So we're going to put this on our calculator. (353 nanometers). So remember, the range we're looking for is between lambda 2 and lambda 1. So this range right here. So that means that the set of wavelengths the range of wavelengths of photons that can cause one CCl bond to rupture, but not the other, that's going to be from 353 nanometers to 409 nanometers. So you have to do this kind of equation, you have to understand that you're trying to find the area as the energy range between the minimum wavelength to break the higher energy, to break the higher bond bonds with higher bond dissociation energy, and the one with lower bond dissociation energy. You have to plug this into your formula, lambda equals NHC over E, and then you can find your two wavelengths, and between that's going to be your range of wavelengths.